All right, go ahead and erase your whiteboards. And just a reminder from the video, in the video we found out that 180 degrees equals how many, oh, my black pen does not work, that 180 degrees equals how many radians? Pi radians. 180 degrees equals pi radians. Okay? And that the reason you have to put the little degree bubble is because if you don't put a bubble, that means that the answer you're putting is in radians. So if you write just 180, that's a whole lot of radians, because 3.14 is like a basic amount of radians. So if you put 180 radians, that's a lot. So we're going to practice first conversion. So I'm going to give you an angle. You're going to convert it. You're going to hold it up on your whiteboard. Aha! We're doing whiteboard drills today. It's going to be a good time. Okay, so before we do the whiteboard drills, we're just going to make sure that we know how to do this. So if I gave you 165 degrees and I wanted you to convert it into radians, how would you convert that? You'd have to multiply it by a fraction. Yes. Yeah, we would want to multiply it by a fraction. We would want that fraction to equal 1, so it'd have to be something equivalent on the top and the bottom. And somehow when we multiplied it by something that was equivalent on the top and the bottom part would have to have a little bubble so that the bubbles cancel. Does that make sense? We want the bubbles to go away. So that means that the 180 degrees would go on the bottom, and we would want our answer to have a pi in it because radians are typically in terms of pi. Not always, but often. So pi over 180 is what we would be multiplying it by. Does that make sense? Now, we would not plug the pi into our calculator because we don't want this to turn into a crazy decimal. We want it to stay as a fraction. So people can type this into their calculator two different ways. You can type 165 divided by 180 and just turn it into a fraction and stick the pi on top. Or you can do 165 multiplied by 1 over 180. It doesn't matter how you type it, but you should be consistent because whatever way you type it, you're going to get into a rhythm of this is how I type it so you can get faster and faster and faster and faster at it. Does that make sense? Two different ways of typing it, but both of them are going to get you the answer that you want. So you can type it the first way, 165 divided by 180, turn it into a fraction. Or you could just do the fraction option, 165 over 180. Or you could do 165 multiplied by 1 over 180, get the answer. Whichever way you want to type it is fine. Just be consistent so that you can get like muscle memory with your fingers and your calculator going, okay? So 165 over 180 is basically what we're doing. So we got 11 over 12 on our calculator, and then we take the pi and we just move it over here, so we have 11 pi twelfths is the radian measurement. Does that make sense? Brains are good? Okay. Can somebody throw me the eraser from the board over there? Because I did not get, yeah, it's split in half, so just the part that has, yeah. That eraser is like, I don't know, 9 years old, so they're not meant to last that long. Oops. Yeah, if you guys haven't seen the eraser up close and personal, this is what it looks like.
Oh, leave the boards off.
Yeah, it's in good shape. It still erases though, and that's the important part. So Yeah, I stole it. That's right, theft. I stole it from one of my old schools. Yep, a whole crime. I said, I don't want to spend $1. I'm taking this with me. So I did. Keep track of these. Yeah, nobody noticed. All right. Okay, let's go ahead and let's convert -10 degrees. -10 degrees, take a moment, do the little conversion. What are you guys getting? Yeah. Yes. Some of you guys think my eyesight is a lot better than it is. -pi/18. Marvelous. Marvelous. Okay. Let's try 320. Yes, yes. Yes, yes. Yes, 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 yes. Yes. The whole video is just going to be me saying yes repeatedly. It's a good video. Yes, 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 yes. All right, here's -1000 degrees. -1000. Yes. Yes. Good catch, yeah. Yes. 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 Don't use your sleeve. That's what the then come get another color, you goob. Yes. 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 The squinty face was my eyesight not doing well. Okay. Yeah, when I'm reading yours, if I go like this, I can't read it, just so you guys know. Okay. All right, let's try 6 pi 11ths. These might be decimals, I don't know. They could be decimal answers, I'm just telling you now. 6 pi 11ths. So, what do you guys think we're going to have to do to convert it back into degrees? We're going to cancel out the pi's, which means we're not going to use pi over 180. You can just leave it. We'll grab it. We're not going to use pi over 180 this time because that wouldn't cancel out the pi, would it? So how are we going to cancel out the pi? Put pi on the bottom. That's going to cancel out the pi. So if the pi is on the bottom, what should be on the top? 180. So this is still mathematically equivalent to 1 because it's the same thing over the same thing. They represent the same thing. We're just converting. So this is kind of like when you guys are in, if any of you guys have taken chemistry and you did the like conversion like train tracks, where you have like 1 hour is 60 minutes, or 1 minute is, 1 hour is 60 seconds. Oh gosh. 1 hour, 60 minutes, 1 minute is 60 seconds. You do those like conversion tables. Do you guys remember doing that? My high school teacher always called them train tracks. But when you guys do those tables, this is exactly the same thing. It's just like the one mathy version that we have. That is not like chemistry. So we're going to cross out the pi's. And so the way that I type this is you can do, how do I always type this? So the two ways you can type this, I'll tell you, because I don't remember how I do it. You can do 6 times 180 and divide it by 11. That's one option. Or you can do 6/11ths times 180. You guys see the difference? Again, it doesn't matter what you do, be consistent, because you're going to get to the point where you want to be fast at this. You want to have like a muscle memory, all right? So either way, those are good. And then my answer for this is a decimal, 98.182. 181 is totally fine as well. I am making sure to put a bubble. I gotta have a bubble. Ooh, yeah. You can do fractions if you don't like rounding. 1080 degrees. 1080 degrees would be fine as well. All right. Next one. Negative 83 pi ninths. Ooh, be careful. There we go. Perfect. Perfect. Be careful. Perfect. Be careful. Perfect. Don't forget your bubble. Yes. Negative sign. Yes. Yes. Okay. All right. 13 pi fourths. 13 pi fourths. Oh, sorry. Hold on. I gotta do the answer. Yes. Yes. that a negative sign?
Yeah.
Is it negative? Is this negative?
No. So that makes it worse. No, it is helping. Look, it's like a nice cute log right now. That was all Shrek.
All right. Okay, here's what we're doing next. We got to make sure we can draw angles correctly, okay? Are you guys ready for this? All right, so we're going to draw the 4 quadrants. Oh, I put them away, so they're over by where the toilet seat is. So here is where 0 degrees are in standard position. And then we go up, this is 90 degrees. And this is a straight line, so this is 180 degrees. Oop, 180 degrees. Right? From 180, if I go another 90 degrees, what do I get to? 270. So 270 is down here. And then if I have gone a complete circle, how far have I gone? 360. Okay. So 0 degrees and 360 degrees are completely different things, but technically they're actually in the exact same spot. Okay. So the name of that 2 angles in the exact same spot is coterminal angles. Coterminal angles. They're in the exact same spot. Okay, so if you were to draw, I'm going to remind you, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We do Roman numerals. We don't do like 1, 2, 3, 4. We do Roman numerals. If you do like the regular, they're called Arabic numbers, 1, 2, 3, 4, like what we write. I'm pretty sure it's Arabic numbers, but I could be wrong. If you don't do Roman numerals, I'll be like, but I won't mark you down. But I will be like, probably. Yeah. I don't know. It's just kind of like, oh, in this situation, that's what you do. And if you don't do it, then the pretentious math people go, ugh. It doesn't mean something different, no. It just means the number. Yeah. These are good questions. Keep asking them. I like. Okay, so if I were to draw a 168 degree angle, what quadrant would it be in? The second quadrant. Okay, so let's go ahead and draw 168 degrees and be like here-ish. So we draw the little line and then we go bloop. There's 168 degrees. You guys see how it took two lines for me to do that? So I had this right here, and then I had to show like, oh, I'm measuring it this way. So this is 168 degrees. Where do you guys think a negative 168 degree angle would be? Quadrant 3. Quadrant 3. So you can also have a negative 168 degree angle. It would be like the mirror image. It would just be down here. And you would just measure it backwards. And it would be negative 168. We just measure it backwards. Okay. Okay, let's go ahead and erase those. You can erase your whole picture if you don't really need the markings on there. I'm going to leave my markings here. All right, go ahead and draw the 4 quadrants, so draw the big plus sign. So draw the big plus sign, draw the 4 quadrants. And then draw a 60 degree angle. And show me when you have it. Draw a 60 degree angle and show me when you have it. Yes. Yeah. Yes. 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 So your 60-degree angle should look something like that. Correct? Marvelous. Okay. Now I want to see a negative 190. Negative 190. Negative 190. Yes. 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 No. No. Yes. Ella, yours was a no. Yes. 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 No. Yes. No. The spot is right, but the arrow's wrong. Yes. 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 That whole table's right. Yes. Yeah. Yes. Yes. So we've got negative 90 degrees, another negative 90 degrees makes negative 180, and then a little bit more. There's your negative 190. Okay. Okay. Here's what I want you to draw. Are you ready? A 360-degree angle. You have to draw the plus sign first, yes. 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 But make sure you went the negative direction, so it's technically negative 360. Yes. 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 You technically, see your arrow? You technically did negative 360. So 360 would be like this. 360. Okay, are you guys ready for this? 370. 370 degrees. It is possible. 370 degrees. Yes? Yes, yes, yes. 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 Yes, yes, yes. Where did you start? So you always start on the x-axis? Yes. So you went negative direction. So yours is negative 370. Does that make sense? You went the negative direction.
Negative starting from 360.
Well, you want to go positive, yeah. So if we do 370, we want to start here and do a full circle. That's 360. And then 370 is just a little bit more. So there's 370. Okay. All right, here's the next one. Are you guys ready? Okay. Okay, think about it. Are you ready? 720 720. Just think about it. 720. What does that mean? 720. Think about it and then draw it. 720. Yes. 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 But where's your arrow? I need your arrow so I know how you started. Yes. 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 All right, so we just looked at we've got 3 coterminal angles now. We have 0 degrees, which is just this, right? That's it, that's 0 degrees. Okay. Then we have 360, which is this, but it like looks the same. You guys see that? 360. So it goes around in a circle, but it ends in the same spot. Everyone see that? Okay, it ends in the same spot, but it went around in a circle to get there. And then we've got this one, which starts here. It goes around in a circle, 360 degrees, then it goes around again, but it ends in the same spot. That's the 720 degree angle. And the name of those, when they end up in the same spot, is what? Starts with a C. Coterminal. They're the same thing. They end up in the same spot. Okay, let's find another coterminal angle. So we're going to start with, go ahead and draw a 45 degree angle. Draw a 45 degree angle. 45 degree angle. Marvelous. And do not erase it. Draw a 45 degree angle and do not erase it. Good. Yes, 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 yes. Perfect. Okay. So we got 45 degrees. Okay. Now, what do we have to do to this angle to get a coterminal angle? You have to add 360 to it. So you have to say, okay, if I'm going to do this again, I'm going to go from here, I'm going to go right through it and do a full circle and then stop in the same spot, right? I have to go a full circle past it. Okay, so let's take 45 and let's add a full circle past 45 and see what that degree measure is. 405? Okay, so 45 degrees and 405 degrees are coterminal angles. They are exactly the same. Okay, what's a negative angle that's coterminal with 45? It'd be negative. Okay, negative 315. Are we in agreement? Okay, negative 315 would be in the exact same spot, just going backwards. Okay. Okay, how do we feel about degree measures? Can we draw them? Okay, we're going to move on to radian measures. Okay. Those were degrees. They got the bubbles, so they were degrees. Okay, we've got 0 radians. 180 goes with pi, so I'm going to do that first. 180 goes with pi. So if 180 goes with pi, what does 90 go with? 1/2 of a pi, so they always say pi halves. Okay, if 180 goes with pi, what does 360 go with? 2 pi. Okay, so the 2 pi is over here. What fraction is between, let me write that pi better. What fraction is between 1 and 2? 1 1/2. how do we write 1.5 as an improper fraction? 1.5. 3 halves. Okay, so we're going to say 3 pi halves. Okay, so here's your fractions. You've got 0, pi halves 1, 3 pi halves 2. Does that make sense? So you've got 1 whole pi on the top, 1 whole pi on the bottom. 1 whole pi on the top, 1 whole pi on the bottom. Okay? Let me write my fractions smaller so you guys can see it without me moving this. Okay. So I'm just going to write the decimals of these nearby so that I can kind of think of them. Oh, I wrote them off screen. So this is, well, that's a 1. This is a 0.5. That's a 1.5. That's a 2. Okay. Okay. This is going to help me think in terms of fractions. Okay. So if I had to graph the angle 3 pi fifths, 3 pi fifths, would that be on the top or would that be on the bottom? 3 pi fifths. Top or bottom? The top. Because if you think about it, 3 fifths is less than 1. Does that make sense to everybody? 3 fifths is less than 1. Okay, so 3 pi fifths. We're just going over strategies right now to think about where these should show up. So 3 pi fifths is what we're going to graph. Okay, so now I'm going to think about what's half of 5. 2.5. Okay, so 2.5 fifths is right in the middle. So does 3 pi fifths go on this side in quadrant 1, or does 3 fifths go on this side in quadrant 2? It goes in quadrant 2. Does that make sense? 2.5 pi fifths would be right in the middle. 2.5 pi fifths would be right in the middle. We have 3 pi fifths that's going to go over here. Does that make sense? So we don't have to convert this into degrees to be able to draw it. We just have to be able to imagine, like, okay, 1/5, 2/5, 3/5, 4/5, 5/5. Do you guys see that? We just have to be able to imagine taking this top part, dividing it into fifths. So 3/5 is probably approximately right here, and then I'm going to say this is 3 pi fifths, and I'm going to call it good. It's a little bit more than half, because 2.5 fifths is half. Does that make sense how I thought about that? So now I don't have to convert it into degrees to do this problem. How are your brains feeling? Brains are okay? All right, let's try another one. All right, let's do 10 pi ninths. 10 pi ninths. Top or bottom? Bottom, how do you know? It's over 9 ninths, okay? So 9 ninths would be right here. It's over that. Does that make sense? So it's over 1. Is it a lot over 1? Because we got 9 ninths over here. We got 18 ninths over here. So it's going to be closer to this one. Okay, so I'm just going to say 10 ninths. If I had to break this up into 9, it's going to be closer to this one. I'm going to say 10 ninths. I'm going to call it good. Nice. Okay. All right. Let's do Thank you. Let's do 7 pi thirds. Let's do 7 pi thirds. All right, so 7 thirds. I've heard a few whispers about it. What's the issue with 7 thirds? It's back on top. So we got, over here we got 3 thirds. Then to get to 2 pi, we got 6 thirds. So 7 thirds is too far. So we got 3 thirds, 6 thirds, 7 thirds. Does that make sense? 3 thirds, 6 thirds, 7 thirds. Okay? So to do radians, you have to think, I'm not going to be intimidated by fractions. You don't have to do fractions perfectly, you just have to try not to be intimidated by them. I always think of them in terms of half, whole, half, whole. If you can think of it in terms of halves, and then the whole thing, you'll be able to do them without doing conversions back and forth. Conversions waste time. That's the only reason I want you guys to be fluent with this without feeling intimidated. Okay, let's look at some more of these. Let's try. You can just go right here. I'll put it up for you.
Or is it just
The notes are the 2 pages on the bottom of that stack. So there's like 2 piles on the bottom of the stack. Okay, let's do 11 pi over 6. 11 pi over 6. Top half or bottom half? Bottom half. How do you know? How do you know it's the bottom half, not the top half? Yes, perfect. It's bigger than 6 over 6. Okay. Is it quadrant 3 or quadrant 4? 4, how do you know? It's almost to 12 over 6, but not quite. Okay, so 11 over 6 is going to be very close to 12 over 6, but not quite there. Okay. All right. I think at this point I've shown you guys a lot of the stuff that would... Actually, hold on. Let's find some coterminal angles with this. So 11 pi over 6. What if I wanted to find the measurement of this, but I want to go the opposite way? Okay, so the positive version of the angle is 11 pi over 6. Listen carefully, you guys, because you're gonna have some questions like this in your assignment. The negative version of the angle is -1 pi over 6, or just negative pi over 6. Does that make sense? This is only 1/6. Okay, now mathematically, the way that you can solve that is you can say 11 pi over 6, and to find a coterminal angle, you can either add a full circle or subtract a full circle. So in radians, what's a full circle? 2. It's 2 pi. So we can subtract off a full circle. What's the fraction in this situation? What's the fraction for 2? 12 over 6, okay? So 11 over 6 minus 12 over 6 is what? Negative pi 6, negative 1 over 6. See how I subtracted off a whole circle? So I did my angle minus a full circle equals the coterminal angle. Does that make sense? My angle minus a full circle equals the coterminal angle. Okay, let's try one more of those just to make sure we got it. Oh. Okay, we're going to do 13 pi tenths. 13 pi tenths. We're going to graph it, and we're going to find a coterminal angle. So 13 pi tenths. Is 13 on the top or the bottom? 13 pi tenths. Where is 13 pi tenths? Top or bottom? Bottom. How do you know it's on the bottom, not the top? It's over 10 tenths. It's over 1. Okay. So we got 5 tenths, 10 tenths. How far should we go? Yeah, we don't want to go all the way because this is 15 tenths, right? Okay. All right, so here's 13 pi tenths. Okay. And then how are we going to find a coterminal angle? We can do 13 pi tenths minus a full circle. And how do I minus a full circle? I'm going to minus 13 tenths minus 20 tenths. And what do I get? Negative 7 tenths. And does that fit if this is 3 tenths right here? Does it make sense that we have 7 tenths left over? Okay, so that angle right there is the negative angle that is in the same position. Its angle's in the same position, but it's just measured negatively. That's negative 7 pi tenths. So we say, okay, a coterminal angle is negative 7 pi tenths. They are equivalent. They just look different, but they're in the same spot. Okay, how do your brains feel? Brains are good? Okay. Because I know trig can be scary, so we want to make sure that our brains are comfortable with the trig as we get into it. Okay, so your assignment is just trying to develop your fluency with degrees and with radians so that you don't feel intimidated as you work back and forth between the two, and so you can kind of understand what degrees look like when you graph them, what radians look like when you graph them, so that you understand all the vocabulary around it, okay?